We are live. Good evening, everyone. Once again, welcome back to the day 10 of our bootcamp session. So, we have our speaker here, Mrs. Lori, PPF Fellow, and then she will be guiding us through the session. So, over to you.
All right, welcome back, everyone. So we've actually come a long way in this bootcamp, and then we most likely will be wrapping this up this week. That's if I'm not able to finish everything today. So that will be like maybe our next session, which is going to be like on Saturday. So for today, without taking too much time, because I think we are already behind schedule for this session. So for today, I'm going to like cover up some of the topics that we left from last week, and then we're also going to look at testing as well as that, like integrating. How do you connect your smart contract to your front end? So that's like the height of it. Like when you finish writing your smart contract, what do you do with it? What do you do next? So in this session, I'm going to walk you through on how to do that. So let's get right into it. Ensure that you are following along as much as possible, especially when we get to the parts where we are going to be connecting our front end with our smart contract using Remix. First off, we write the contract with Remix, and then we move it to VS Code, which is the text editor that I'll be using for this. So now let's get into that. All right, so once again, these are the things we're going to be looking at. So first off, this was part of the topic that we are supposed to handle last week. So first of all, what is DeFi? So these are just like concepts that I'm going to explain in this session. It's not like we're going to go deep into it. So if you are really curious about getting to understand each of these concepts, I would advise you go read more about it and all that. So first of all, I believe if you have like if you have joined us for the bootcamp from day one to this point, you probably would already know what DeFi is about, or if probably this is your first video or this is the first time you're just joining the session. So in the blockchain space, we talk about DeFi, we talk about TradeFi. So when we're talking about TradeFi, we're talking about traditional finance. And then when we're talking about DeFi, we're talking about decentralized finance. And I think by now we already know what decentralization is. If you are not sure what that is, I don't want to go into that, but you can watch the first video of this bootcamp. So when we talk about decentralized finance, we are talking about financial applications that are built on top of the blockchain or that are built on the blockchain. An example of those type of we have quite a number of them these days, a number of DeFi applications, a number of DeFi projects that you probably would have used or interacted with. And you can see the likes of maybe Trust Wallet, you can see the likes of On Board. Those are DeFi applications. There and so many others, even Binance and all of that. Even though it's a sense application, DeFi is kind of like broad and divided into. We also have these centralized exchanges, which are also like part of DeFi applications and all of that. And then we have AMM. So we are talking about market makers. So this really have to do with the approach in which like when you use things like Uniswap or swapping applications, how do they figure out what the swapping rate is and all of those things that happen under the hood. So that's what happens when we are talking about what's it called, AMM. So AMM is automated market maker. So that's the full meaning of AMM. And then we are also going to look at lending protocols. So what are lending protocols? So we have a lot of projects these days that what they do is they give you the ability to be able to borrow, to lend and to borrow, just like we are used to lending and borrowing in our traditional financial system. In the decentralized world, we also have DeFi solutions that are focused on lending and borrowing. Example, we have Compound, and we have quite a number of other projects that are also focused on lending and borrowing. And then we talk about yield farming. So yield farming is basically your ability to be able to provide liquidity to like add some liquidity with inside the pool. Like we have a pool where tokens are trying to like raise some funds for the token, for that token to become listed and all of that. So the process of doing all of that, like providing liquidity and making profit off that provision, or it's almost like saying you are investing into a project or investing in a token and all that. So that's what happened with liquidity and yield farming. And then so you do that mostly with projects, all these like I mentioned earlier, like the likes of Uniswap, where you are providing liquidity to those tokens and all of that. Then we have tokenomics. So tokenomics is like the economics behind tokens, like all of the processes involved when creating a token, like the total amounts of the token, the unit price, and so many other things that comes with token. So it's like a broad subject, like I said, and then this session might not be enough for us to like go deep into each of them. But I think with this little explanation I've given you, you probably already like have a fair knowledge of what tokenomics is, what yield farming is, and and lending protocols and all of that. So if you have any question regarding that subject, feel free to drop it in the comments, and we'll be happy to answer you. So without wasting much time, I'm going to dive into this. So this is supposed to be like the next topic, and then I don't want to also spend too much time on this because some of the things we're going to be doing in week 7, which involve integrating, writing our smart contracts, bringing them, marrying them together to be able to interact, just like you creating a backend and then creating a front end and then interacting with your backend using an API. So we'll see how we do that in terms of smart contract and front end. So because we usually have issues of people asking questions like, oh, I'm a backend person, how do I get into the blockchain space? Or I'm a front end person, how do I get into the blockchain space? So those are fair questions or good questions in the sense that, like I normally say, if you're a backend person and then you already know any particular language that you are probably familiar with, like in this blockchain space, a lot of projects aside the Ethereum based or EVM based blockchain, a lot of other blockchains, some of them use Golang, they use Rust for their smart contract, and then even the EVM now we have Viper. So Viper is Python based. So if you are a backend person that is familiar with Python and you feel like, oh, I don't have the luxury of time to go learn Solidity, then you can just learn Viper. It should be familiar since you're already familiar with Python. So with that, you can bring your backend knowledge into the blockchain, just like you thinking through a project and like trying to think maybe you are creating a student application, for instance, like a student record application. You need to know how many students are in the class or get a list of all the students, like have a database for the student and all of those things. So the same way you think through your project when working in the in the Web2 world, Nothing different from that when developing a project or I'll come to that, when developing a project in the Web3 world. So what I just want to say is that you can just bring that same knowledge or that same thinking process into the blockchain space. So the same thing applies to front end development. So if you're already like familiar with front end development, so it's just you now trying to learn how to interact with that particular blockchain. And in this case, we are talking about the EVM based blockchain. So how you interact with an EVM based blockchain is part of what we are going to be learning today. So the goal is so as part of like, because in the class I had the other time, I talk about testing, I talk about gas optimization and all of that. So I didn't really like go deep into testing though. So basically, every smart contract needs to be tested. In Web 2, we don't really take testing that serious. Most of the time, we have been told to form this habit of test-driven development. But most time we fall guilty of that. We just go straight into writing the code, writing the logic, and then we'll say, perhaps sometimes we tell ourselves that, oh, I'll write the test later. And then at the end of the day, you forget about writing tests, especially when you're finished writing the code for the full project and you feel like, oh, everything is working fine. So there's no need for me to test. So, but in the blockchain world, it's not like that, because everything you do on the blockchain is a transaction. So if you don't get anything out of this session, just know that everything you do on the blockchain is a transaction. So even if you are writing an Hello World application, you are sending it to the blockchain, is a transaction. Why is it a transaction? Because you're going to be charged gas fee for it. So just like you transporting, or just like you, yeah, let me use like, let's say you're interacting with your normal Web2 application, even your app, like your bank app, for instance, and then for your bank app, you just can't send hello, but you can send zero amounts if you don't send any amounts. And then for every transaction, they have a range for the charge. So I've not tried it before, but I believe even if you are sending a zero amount to somebody, you are going to be charged. That is if your bank allow you to send zero. You're going to be charged for that. So the same thing applies here. So if you send a message, it's like you making a post request. So it's not like our regular backend where you can just make a post request and it goes to your backend database, your centralized storage, or your whatever backend storage you're using, maybe Google Cloud or AWS or any of those cloud platforms or backend services. Now, it just goes there. Nobody sees what has happened. There's nothing like a transaction hash or transaction history that you can track. So you can decide to tell somebody that I did this transaction or I did this thing when you did not actually do it. And that's one of the powerful and difference between a decentralized platform and a centralized platform. So if you are building a project and you probably have investors, and then you're telling the investors, you probably want to just like falsify some figures and say you have 10,000 users that are interacting with your application. In a centralized world, that might be easy to do, to just lie and probably to just populate your database with something. But in a decentralized world, that might not be so easy, because everything, like I said, is a transaction and you can find them on the Explorer. And on that Explorer, you get to see every contract or every account that have interacted with your contract. So your project will have a contract, and then every message you send, like I said, is a transaction. And if you want to do an actual transaction where you are like transferring a token from A to B, that is also another transaction. And the record of those transactions are going to be seen on the Explorer, where you get to see the transaction history and everything, who sent what, using is anonymous, because you're just seeing their transaction, their wallet address and then you see the time it was sent, how much, what block that particular transaction was finalized, and all of those information. Like I said, all of this talk I'm just talking is just a way of me telling you that testing and security is something we don't play with in the blockchain space. So you can write a project, whatever it is, and not write test in the Web 2 world and get away with it. But in Web 3 world, before your projects can like go to the market and people start interacting with your contract, it has to go through some process of auditing. Like people, we have a lot of auditing firms online that audit smart contracts. So they have to like audit your smart contract, verify that this smart contract is free from bug, is free from reentrancy, overflow or underflow or any kind of issue that might interfere with your users and their fund. And because, like I said, everything is a transaction, you have to be careful how you write the contract and ensure that it is properly tested. Both written after you finish writing your test, you still need another pair of eyes to go through it, an expert organization too that is focused on auditing of smart contract. They also have to go through your contract, especially when it's a big project where you know you are going to be dealing with people's fund. You don't want to just play with people's money like that. So all those things are very, very important because in the Web3 world, it's very easy for you to lose fund, both personally as an individual. If you are not careful, somebody is sending you money and then the money goes on your account, it has disappeared because there are a lot of fraudulent activities happening on chain where people are just like writing malicious contracts to defraud other people. So one has to be careful in the Web3 space. And so like I said, these are like testing tools that you are going to be familiar with by the time we finish this session. You might not be like completely familiar with them, but I'm going to introduce you to them. So when we talk about testing, unit testing of your contract, the major ones that we use is ADAT and Foundry. I've not used Truffle before, so ADAT and Foundry. So I'm going to like open the documentation for you, walk you through the getting started, and then like I will advise most of the time when I'm working on a project, I don't have all of these things in my head. I just go to the documentation and follow the normal steps that is there. So that's the approach you should be taking. So you shouldn't like most of the time in Web 2, when we're doing Web 2 stuff, most of us we just like, oh, we just run, like we just start coding, we don't read documentation and all of that. So in the Web3 world it's different. So because the space is still evolving, a lot of things are changing every day. So something that you use today, you might write a contract that is working today and then tomorrow you see that it's not working as it's supposed. That's because things are changing every now and then. So you have to be up to date with your contract and with the tools that you are using to ensure that you don't experience breaking changes and all of that. And then so I'll be showing you ADAT, walking you through the documentation. So it's very good for you to like be familiar with the doc. Always make reference to the doc when you have to. Yeah, so these are some security issues you should be aware of. Like we have reentrancy. That's like when you've done a transaction and then like it's almost like say there's a leakage when your contract has been exploited or probably you wrote it in the wrong way, and then that contract can be prone to what we call reentrancy, which means somebody transfer money and the person can even send money back to their account even before the money gets to your account. So there's a way you write your contract and you will experience this. And to avoid that, if you remember in the class, the other class I had, I talked about DeFi. So there's an import for reentrancy by Open Zeppelin that you can import into your contract to avoid a reentrancy attack whereby your contract can be exploited. I will also advise you check Solidity by example. There's an example contract that was written to better showcase reentrancy. So we also talk about overflow and underflow. And then I think I did that in the other class I had. So as much as possible, these are things that can exploit your contract, the reentrancy attack, the overflow and underflow. So you need to watch out for these things. And then I think that time we introduced a library. So and there are other ways you can write your contract too to ensure that you are mindful of this. So these are just like small of the many vulnerabilities that can actually happen to your contract. Then, like I mentioned earlier, also utilize security tools or auditing tools that can save you a lot of costs. Meanwhile, this, like I said, these auditing platforms, they are not free. You pay for them, but it's worth it. So, and like I said too, you need to go to this point when you know that the contract you're writing is a go-to-market product. So if you're writing an hello world contract, you might not really worry much about reentrancy or overflow because you're not dealing with refund. So if we're going to be going through the week 7, which is the interacting with our front end and back end, our front end and our smart contract, we are going to be using SEPO layer testnet. So we wouldn't really worry much. So it becomes very important, like I also mentioned, if you want to go to the market, your contract needs to be okay, like very okay. So and then you need to like refer back to some of those videos we some of those sessions we had where we talk about all these subjects. And yeah, I also mentioned gas optimization. So this is where you have to like consider your users, the people that are going to interact with your smart contract, and be sure that helping them to save on gas so that they are not spending so much while interacting with your app before they start complaining that the gas cost is too much and they are scared to even do anything on your application. So this is very, very important as well. So I don't know if there's any question at this stage before I move on to the week 7, where we are really going to like have a simple smart contract and then a simple test and then a front end. We connect our wallets, we transact, we check the explorer and see how all of these things work. So basically, about connecting our backend and connecting our smart contract to our front end, we are actually just talking about dApps. So what are dApps? So some people call it the apps. Me, I call it dApps. Yeah, so dApps are decentralized application. And then by now, I believe probably already know what decentralized app is. So decentralized applications are applications that interact with the blockchain. That's just like a simple explanation for that. And then what does the architecture of a dApp look like? So you have a front end, you have a back end, and you have a blockchain. But all the time you have a back end. There are times where you're just creating a simple application that you're just interacting directly with the blockchain. You're not like interfacing with any backend service. There are times where you couple all these 3 things together. Then we have example of dApps. We have Uniswap, CryptoKitties, and many other dApps out there. So tools for dApp development, we use ADAX to deploy our smart contracts, test our smart contracts. You can also use Foundry for that. Use Web3.js. That's what you use when interacting on the front end. Or use Ethers.js as well. Then we connect to MetaMask most of the time, but the other wallets that you can actually connect to, and then you can do transactions. We can listen to events and all of that. So that's these are the things like that you do on the front end within your application. So as a simple workflow, most of the time I just like to write my smart contract inside of Remis, and then I can deploy it right here on Remis if I want. And sometimes I can just go to what's it called, VS Code, deploy it there. So the reason I like to write it here is all these error intelligence, or what they call it, that I get to see if there's any issue. It's very, very easy to detect with Remis. And if you're going to deploy it here, I don't make the mistake of deploying it to all these dummy wallets. This is just Cancun. This is not connected to any wallet. So if you want to connect to an actual wallet, you need to change to injected MetaMask. So this is where your MetaMask now actually comes in. I think everything we have been doing is things we have been using the Remis VM virtual machine wallet. So if you want to use the proper wallet, you need to select this injected, and then that's will pop up for you to enter your MetaMask, and then select the network that you want to deploy your contract to, and ensure that you have a test token. So these are some of the housekeeping stuff we are going to be doing today before we go deeper into actually interacting with our smart contract. So I think the first thing first, I mentioned we're going to use Sepolia, right? So let me see. And Dami, please let me know if there's any question in the comments.
All right, currently there's no question at the moment. But
Okay, all right.
yeah.
No problem. Okay, so right now, this is my Sepolia. So like I said, let me zoom. Let me know if this is bold enough. Is this bold enough?
Yes, it is. It's close. I think your screen is half. It should be full. screen, Like
Is it okay?
69. Yeah, it's
You
okay.
said?
It's okay. It's okay.
Okay. That's because this was open, that's why. Alright, so yeah, so this is a simple hello world contract that we want to take to our VS Code. But like I said, I like to always work from here. You can also write your smart contract straight on VS Code. So how you even do that? Let's say, if I let us finish this here, I like to finish it here, test it, ensure that everything is working before I take it to VS Code. So VS Code is just to couple things together. So now, assuming we agree with this, so we have this hello world contract, and then we have this state message here. So this might not be necessary to be a state, like I told you. One of the ways of saving gas is to minimize how you use your state variable. So but I think because I'm going to be adding this to it, you might actually leave that state variable to it. Okay. All right. So now we have a message. This is almost like you writing a backend API where you have a set and a get, or where you have a post request and a get request. So see this set message as your post request, and then see this one as your get request. So now we are sending a message, and then we are going to get the message. So this is just going to get one message. If we want to get all messages, that means we want to create a list of message. And that means we won't just be doing this. We are supposed to be pushing to the message. So let's say um, I hope I'm doing this correctly. Okay, so this should work. Yeah, so this one is just a single message, and this one is us getting all the messages. So I think in this contract we are creating, because if we don't do these messages, if we don't get the list of messages, it means we are going to be overriding, like every message, like the last message is what you are going to be getting. The previous messages, we look as if they are lost, but you can still see them in the transaction history. But um, when you try to get, you only get the last one. So that's what happened with this particular function. And then, except you want to get the message by the ID, then we now have to start doing all of those ID things. So, but if we're not doing all of that, we can just push to the message. So, and I think what we can pretty much do, we are going to have, I think our contract is going to be something like this. Let us replace with this one. So I think this should be better. So meanwhile, we can get rid of this. We don't need this message because we want to be able to get all the messages. So now what this function does is, first of all, you add a message. So this is a new message. We are pushing it to the messages array. So initially in the contract, when we create this contract, an hello world message will be created. So this is what happens at the start of the contracts, or after deploying the contract and all. Then when you do get message, you can get message by the index of that message, like the position of the message in the array. So if you now check the message of length, so if you are trying to put an invalid length that does not exist, let's say you have two messages and you're trying to get message 3. So this is going to give you this error index out of bound. And then with this, we can get all the messages. So this is a string array, an array of string. So because what we're pushing into the message is just a string. And then we can use this to get message count. That's if we want to get the total length of the messages, just the total length. So that's just what this contract does. So let us compile. So let's go over to, yeah, so I've compiled it, and then I think we're ready to deploy. Okay, so now I'm not able to deploy right now because I'm currently connected to Sepolia, but the wallet is not showing. So I will need to, the wallet is not showing. So I will need to check my MetaMask and see. But before I go over to that, because I will first of all I will even need to fund that account. So but before I go over to that, I need to go back to this for us to easily like test out what we have done to be sure that this contract is good. So when the contract is good, then we cannot worry about how do we test this contract, and then how do we interact with it on VS Code and all of that. So now I'm going to deploy the contract. The contract has just been deployed. So yeah, we can, once I do get message, we're going to get this LO1 because that's the first message that will push. So even without me typing anything, you're going to get the LO1. So as you can see, we have this LO1. And if you do message counts, get message counts. Okay. I think it should be it. Yeah, I'm going to show you one. So that's because we just have one message inside. So let me add another hello glory. So this is another message I just added. If I do get message, we have hello world and we have hello glory. If I do get count, we have two now. So if I just want to get index one is going to be glory, hello glory. Index, because index starts from 0. So yeah, so as you can see, our contract looks, so this is still going to give us hello glory. Yeah, so everything looks good on the contract. Now let's see what else we can do with this contract. So if you want to test your contract, most of the time you do that. um okay, let's see. If you come over to this, as me I'm using Remis, I just want to show you how they handle tests in here in Remis. But meanwhile, we're actually going to be doing it later on in VS Code. So everything we're doing here, we're just going to copy them and paste them on VS Code. So we don't really have to waste much time once we set up our VS Code and our adder to start communicating or to deploy and all of that. So this is just me showing you how you do it here on VS Code, sorry, on Remis, and now you're going to do it on VS Code. So first of all, you know this Remis comes with some default contract. You have the storage contract, owner contract, and then ballot contract. And each of these contracts have their tests. So this is test for this ballot, and this is storage test. This storage test. So you can follow how the test is being done here when trying to create our own test. And then I think an easy way to do that would be, so let me rename this and call it okay, hello world. Let me add tests underscore test to it. Okay. Yeah, so what I want to do now is I want to copy this storage and then make modifications based on our own contracts. Okay, so first off, our contract name is what? Our contract name is what? The one we just created now. Let me go over to that. Okay, our contract name is hello world. So copy this, come back to our test. You type hello world here. You know, the essence of testing is to ensure that the contract is going to behave the way you expect it to behave. Ideally, in a normal TDD approach, you are supposed to like start with test, which is like test driven development. So, but in this context, we already have our contract. That is one is a, what do they call this one? Code driven development. All right. So yeah. So for testing, you need to do things like expect charge. I think that like regular testing stuff. Then this one is ESAS, and then this ADAT. So I told you for testing, these are very good for testing and for contract deployment. And ESAS is usually used for front end interaction. So we are going to also change this get factory contract to hello world. So you have something like this, await, enters the get. So this get contract factory is a method inside um this enters library, and then we can say hello world and deploy. So this is going to deploy this method. We are going to await it here to deploy the contracts, and then we can now say hello world deployed at hello world address. So this is going to print out the message. So this log is just like a regular log in JavaScript, and then it's going to print out the address, the deployed address, and hello world or retrieve. So we don't have a retrieve method. So this is where we start to play around with our own method. So now in our hello world contract, we have a method test. So this test, it's so you are doing this normal describe. So if you have ever written a normal JavaScript test, this is very similar. This is just like a regular JavaScript testing. So the test is saying it's test initial value. Okay, so in our one case, we are going to do test initial message. I think this should work. So I'm going to do get. We have a method to get. Let's say get message. Oh, what did I do? Okay, so we have a message to get. We have a get message method. So we are going to pass it here. Instead of retrieve, because we don't have a retrieve method. If we run that contract, we're going to get an error. So and then our get message is expecting something. So and then we are expecting to equal what? So this is, we want it to equal something. So what we actually want it to equal is actually the message, this text that is here. So if we put something else, it's going to give us an error. So you know when you're writing text, you are saying you want this thing to equal this. Then test updating and retrieving updated value. Okay, so these are our first tests. So this second one we can test to get the length of the message. Okay, so test updating. So let's say we are going to change. We are going to, so every because we are not doing. There's what they call, what's that word now? Before. So before each, because we did not have that before each year. But as we have it before each, something like this is how we are like supposed to. As we have something like this in this our contract, we don't have to be deploying the contract every time. And so doing this should take care of that. So that's if we just want to write the deploy just once. So because we don't have this before each, let me comment on it. So because we are not using this right now, that's why for each of these things we want to test, you have to deploy the contract. So that's why we are going over this deploy logic again. So in the real sense, you should make use of that before each. So that one is going to save you the stress of always redeploying. So you can just write that once instead of repeating yourself. Imagine you are testing many different cases. So that's going to be like a lot of repetition. Okay, so what's the next? Yeah, so okay, let's say hello world, and then I think it's just pretty much the same. Let me just copy this. So we can, I think we can still test this particular condition when we are adding a message. So we are going to get an add message method, and then we're going to replace our store with add message, and then hello world with this, and then the message we're adding is glory. So let me call this one send message, and then we await it, and we have okay. So do send message dot get is it get yeah get message. So this time around I want to get message at index 1. So this should equal, we are expecting the message to equal this particular text we entered. Another test we can actually do is to get the message count and expect that the message count should be equal to 3. So we can add that here. What's the method for that? Get message count. So this does not have any param. I think that to number works. So convert that to number should equal to. So we are expecting 2 counts. So if everything is good with our test, fingers crossed, the test should pass. Okay, so looks like we have a bug. Okay, let me see. Cons expect require blah blah blah. Identifier expected identifier got this. So I think the error is actually coming from this line. It's actually pointing at this line. So let's see. I really didn't change anything from there. So let me see. Let's go back to this file. We copy the storage. Oh, my bad. So this is supposed to be .js. If you notice, this code is actually a JS code. No wonder I was having that same error somewhere. Okay. Yeah, this is actually supposed to be .js since I'm doing this normal JavaScript stuff. There are two ways. Like I told you, we have Foundry, um, we have ADAT. So ADAT test is almost similar to regular JavaScript. And then when you're writing ADAT test, you can do .js. And if you are writing test using Foundry, your the extension can still be .so. So because the way Foundry writes their test is similar to the same way you write the smart contract. So you still do .so. So now that we have changed that, let's hope that everything is good now. Okay, I think something is running down here. Let's take a look. All right, 0 passed. Okay, so let's see what's going on. Let me hide this. Okay. Hello, test initial message. It's not a function. Storage.deploy. Are we still using storage? Oh, okay. See the error here. I still have it here. How come? Okay, yeah, that's where your error is coming from. Alright, so one test is passing. Initial message. So for the contract that is deployed, and then it is deployed address for the contract. And it's testing the initial message. So this first one is passing. So the initial message is this. And then we're trying to update it now. And we are getting failed. So let's find out why it's failing. So this is how you debug when you are deploying your contract or writing tests for your contract. Things like this always happen. So let's get to that. So test updating and retrieving updated value. Gets message is not a function. Every word that gets message count is not a function. So let's see. So I'm wondering why gets message is not a function and it's the same get message that we use here in this other one, in this first one that passed. So I'm wondering why it's not a function in the second one. Okay, and then uh, send message. Okay. Yeah, I think I'm supposed to do hello world. My bad. I went to use send message. So this should work. I think the second test should pass. Yeah, we have to test passing now. When you're writing tests, it's always very sweet when you're seeing this green check. And then the third one we are testing hello world dot get message count. Dot get message count. Let me roll this to number. Maybe that's the problem with it. Okay. Expected one to be equal to get message count is 1. Okay, it's actually going to be 1 because this one is a standalone stuff that is not like getting all the lists. And if we're getting the list now, we can now check the list because here now we just deploy. So once we deploy, the only thing that you can see inside the contract is going to be 1, not 2. So assuming we after deploying we did this, we add message. then we can make it 2. So I'm going to add this one to this and then expect it to be equal to 2. But before we do that, let me just run it now. Everything should pass well now. So we have our 3 tests passing. So now if we want to like test for when another message is added, and then expect that this one should be equal to 2. If I do equal to 1, now this should fail now because we are already adding 1 to it. So it's expecting it to be 2. So if I run this now, everything is passing. So we have our test passing. So this is what you do when you create your contract, you write some tests to ensure that everything is good. So with this now, we are sure that our contract is good, at least the very basic minimum contract that we have created. So what do you do next? Now that you have your smart contracts good, your tests good, now we are not going to end this. Our contract is not just going to end up here. We need to be able to interact with the front end. So how do we interact with the front end? I think that's where ADAT comes in. That's where Foundry. Foundry is not is for the smart contract deployment and testing. It's not really for the front end. So when we are moving on to the front end, we are going to be looking at Rainbow Kits, how you can connect your wallets. We're also going to look at Nest.js. We are going to be using Nest.js, building a simple Nest.js application, having a connect button like this where we can connect our wallets, making use of Rainbow Kit, and now we can send a message, interact with this contract that we have created to send a message and get back the message and see all the list of the message that we have sent and check the Explorer for the message that we have sent. So I think we're pretty much going to end this session here. So it looks like I will have to take this interaction part to the next class, which is going to be on Saturday. So then I can show you how we can couple all these things together. So in this class, we'll be able to learn a bit about what testing entails, about this concept, and then how to test our smart contracts. So if you have any questions, please do it to drop it in the comment section. And yeah, so that will be it for today. Dami, I don't know if there's any question on the chat.
There's no question on the chat, so I think we can end it here.
All right, thank you very much, and I'll see you guys on Saturday. Come prepared for that. Is going to be really interesting to see everything that we have been doing since come into life. Like you have a front end for it where you can actually interact with all the smart contract that you have been creating. Probably you have been struggling to do that on your own. So I think you will learn a lot from that session. Yeah, so thank you very much.
I thank you, man. Bye, everyone. See you on
All
Saturday.
right, bye.